Welcome to Altium Designer Adding Hierarchy. In this module, we will update the Raspberry Pi daughterboard project that we had been working on by creating a hierarchical design from the current flat design. The WC topping design consisted of 5 schematics and was simple enough so that it didn't require using a hierarchical design approach. We can, however, use this example design to demonstrate the process for creating hierarchy in Altium. Altium provides for both top-down and bottom-up design approaches. In fact, these approaches can be mixed without difficulty, as we will see later in this module. Using the example SL1 project, we can explore the various elements of a hierarchical design. Here we are looking at the top-level schematic. We see both components and blocks. The components we've seen before. Clicking on them populates the Properties window with their information. These blocks are called schematic sheet symbols, and they reference a schematic file, as you can see from the Properties window, after clicking on the sheet symbol. Here we see the reference designator and the file that is linked to this sheet symbol. Clicking on the sheet entries, we can see a listing of all the connections of the reference sheet. Let's select the HA2 sheet entry on the block. Sheet entries represent ports in the lower level schematic and provide a means for connecting the reference ports at the higher level. Each sheet entry has a name and I/O direction type listed. Using the sheet symbols enables a designer to add levels to the project, allowing for a cleaner representation at the higher level with large blocks containing numerous schematics. Another feature of sheet symbols is the ability to connect differently named ports when using wires or buses at the top level. One example of this is the FPGA_DIN signal wire between the FPGA block DIN sheet entry and the SL_configs DO sheet entry. Hovering over the LCD switch LED sheet symbol, we see that it brings up a thumbnail view of the schematics. Clicking on the schematic file listed jumps down to the reference schematic and opens it up. There is another faster way to jump down into the schematic. Let's going back to the top level. If you hold the Control key down and then double-click on the schematic sheet symbol block, it brings you to that lower level sheet. I find this is faster as it doesn't require waiting for the pop-up thumbnail to come. On this lower level schematic, if you hold the Control key down and double-click on a port, you will traverse up the hierarchy and highlight the sheet entry for the port and all of its connections. Clicking on the schematic sheet clears the masking and highlighting. You can use the Control double-click method to follow the signal level down through a sheet entry like this. This is a handy way to trace a signal through the design hierarchy. As a quick review, designs can be flat or hierarchical. Altium allows for both top-down and bottom-up design flows. To illustrate the top-down design flow approach using our WC topping flat design, we will add a top-level block as well as 2 intermediate level blocks. As a quick refresher, let's look at the block diagram for the WC topping design showing the 5 schematics. To create a hierarchical design, we would need to add at least one level in the form of a top-level schematic. A top-down design flow starts by creating a top-level schematic containing sheet symbols. Sheet symbols point to either existing or future planned schematics. As we are starting at the top and working our way down, the sheet symbols will point to non-existing schematics. The sheet symbols can have sheet entries that represent planned I/O signal connections between the top level and the lower level schematics. In a pure top-down approach, we would continue to create schematic sheet symbols, adding sheet entries for I/Os until we get to the lowest level where we have components captured. A pure bottom-up design flow starts by creating lower-level schematics with ports, and then using these schematics to auto-generate sheet symbols with sheet entries on the next higher-level schematics. Continuing to add upper-level blocks using Altium to generate schematic sheet symbols from the existing schematics. We will employ a hybrid approach for this lesson, starting at the top, creating a second level, and then we'll switch to the bottom-up method of generating schematic sheet symbols from existing lower-level schematics. Starting with the top-down design methodology, we first add a new schematic for the top level and call it top level, of course. And then we'll create 2 schematic sheet symbols for the mid-level schematics, so that we will be creating a hierarchy like you see in this diagram. To add the planned mid-level schematic sheet symbols, right-click on the schematic and select Place, Sheet Symbol, and then click on the Tab button to open up its Properties window. enter mid1 for the designator, and then we would specify processor_power schematic doc for the file name. This file name will be used when we auto-generate the mid-level schematic. Place this sheet symbol and repeat for the I/O logic block sheet symbol, placing it next to the processor power sheet symbol. Again, this would be mid2 for the reference designator. Now we can add sheet entries for the future connections between the blocks. To add a sheet entry, click on Place, Add Sheet Entry, and then hover over the sheet symbol. Hit Tab to configure the sheet's entry properties. We will add the \CS signal name. Note this was already filled in, and we'll make sure that we are pointing the output for the direction. Note the placement of the sheet symbol entry is only allowed when hovering over a sheet symbol. We could continue to enter the rest of the sheet entries manually, but given the fact that the schematics exist already, we can make use of the power of Smart Paste. Opening up the processor interface schematic, select All, and then Control-C to copy it. Now back at the top-level schematic, we use the Smart Paste, enabling only ports as the source, and sheet entries for the paste action. And now we can place these on the sheet symbol. We can delete the extra copy of the CS bar sheet entry as we only need one. Rearranging sheet entries is as simple as clicking on one, holding down the left mouse button, and dragging it with a mouse. Now we have the schematic sheet symbols. Let's continue the top-down design flow and use the mid1 sheet symbol to automatically generate the reference schematics using Altium. Right-click on the mid1 sheet symbol and select Sheet Symbol Actions, then Create Sheet from Sheet Symbol to generate a schematic, and also use the sheet entries to auto-populate the ports on this new schematic. In the new schematic, we can see the auto-generated ports. Here at this point, we will switch from a top-down to bottom-up design flow to add to this mid-level schematic the two schematics that already exist that we need on this level. Right-click on the schematic sheet actions and pick Create Sheet Symbol from Schematic, and pick the processor interface schematic. Placing it, we can see that the Altium generated the schematic sheet symbol for the processor interface schematics. Note that the ports on the original schematics are used to create sheet entries. This is handy as it ensures that the ports and the sheet entries match. Now let's add the power supply as well using the right-click Sheet Actions. Create Sheet Symbols from Sheet. Notice that there are no sheet entries. Jumping down into the power supply schematics, we can see why. There are no ports, only global power connections. Wiring up this intermediate level block and adding ports, we can now employ the same copy and Smart Paste for the upper level sheet symbol entries. Let's generate the I/O logic block schematics from the schematic sheet symbol and then populate it with the needed subsheets. Selecting the sheet symbol and then right-clicking on it to pull up the pop-up menu, we select Sheet Symbol Actions, Create Schematic from Sheet Symbol. Now in this new schematic, we will switch from the top-down approach to the bottom-up approach, and we will use the existing schematics. Saving the new schematic after we edited the title, we can now start adding sub-schematic sheet symbols. In the schematic, right-click and select Sheet Actions, then Create Sheet Symbols from Sheet. In the pop-up selection menu, we'll pick the CAN interface file, place this on the sheet, and note that it already has the sheet entries as we had seen before. We will continue and add both the digital I/O and the relay schematic sheet symbols as well, placing them and resizing the relay as you see here. Again, just click to select the sheet symbol and then pick on a corner or center square to resize it. Now we can arrange the sheet entries and wire up the connections between the schematic symbols using wires and, if needed, buses. Once we have completed the wiring and added ports to this schematic, we can now select all of it and copy it. And then moving back up to the top level schematic, we will use the Smart Paste again to create the needed sheet entries for the I/O logic block. Now arranging and aligning between the two blocks at the top level allows us to use another shortcut for wiring. Moving the two sheet symbols together, being careful to align their sheet entries, we can now, holding the Control key down, select a block and pull it away. This auto-generates wires as you can see. We will need to add wires and a bus to connect up the relay signals as you see here. Again, remember to add net labels to the wires and the bus. With the top level wired and the mid-level schematics created, we can now compile the design. If there were errors, the message window would have been activated. Given there were no errors, it did not open. If there had been any reported errors, we would have followed the same approach as with the flat design to track down the source of the error and fix it. Clicking on the top-level schematic in the project panel expands its sub-level entries. This shows the hierarchy and is a help in navigating when looking at the new design. Looking at the message panel, we can follow a typical warning that we would see. Double-clicking on the warning highlights the net, and we can follow it to its source by holding the Control key down as we mentioned before, and clicking on the sheet entry, and to follow it all the way down to where it is sourced. Note, this is a typical warning caused by the connector pins not being active sources, so the ERC check flag shows this as having an input without any driving source. In this module, we showed how to use Altium for hierarchical designs, both top-down and bottom-up. Using the schematic sheet symbols and sheet entries allows for multi-layer schematics and a clearer layout of your design. Please do the exercise, adding hierarchy.